Good day, Danians! For this week's video, we will be talking about operations on functions. This time, we will have the division and composition of functions. We have 3 goals for this week's lesson. These are, first, we are going to review the process of addition, subtraction, and multiplication of functions. Second, we are going to perform the division and composition of functions. And third, we are going to find the domain of the resulting function after we are going to perform the operations on functions. Enjoy learning! Now let's talk about the restrictions in the domain of functions. So far we have talked about linear, quadratic, and even cubic functions. So these types of functions do not have restrictions in their domain. This means that these functions could take any values of x. However, we have also functions which could not take all values of x. Example of these functions are the rational and the radical function. So in a rational function where we have a numerator over a denominator, the denominator should not be equal to 0. So we should look for values of x which will not make our denominator be equal to 0. Because if our denominator will be 0, we will have a resulting function which is an undefined function. On the other hand, a radical function has a restriction in its domain only if we have an index which is an even number. So if our index is an odd number, then therefore we do not have any restriction in its domain. However, if we have an index which is an even number, we should look for values of x which will not make our radicand be equal to a negative number. Because if our radicand will be equal to a negative number, then this will give us an imaginary number. So we should avoid values of x which will make our radicand be a negative number if we have an index which is an even number. Let's start by having our review. Try this. Find the indicated operations and give its domain. Given the function f of x is equal to 2x plus 3 all over x, the function g of x is equal to x minus 2, and the function h of x which is equal to x. Find number 1, f plus h of x. Number 2, f minus g of the negative absolute value of negative 3. And number 3, g times h of x. Now let's solve for number 1. So we are looking here for f plus h of x. Or by definition, we are looking for the function f of x plus the function h of x. So we are going to substitute here the given functions f of x and h of x. So the given f of x is 2x plus 3 all over x. On the other hand, the given h of x is equal to x. So we cannot add automatically these expressions because we are having here a rational and we are having here a linear expression. So therefore, we have to express this first as a fraction whose denominator is like that of 2x plus 3 all over x, which is x. So the process goes like this. So we are going now to express x as a fraction whose denominator is the same with 2x plus 3 all over x. So we will treat x as a whole number and 2x plus 3 all over x as a fraction. So now we are going to express x as a fraction whose denominator is the same with 2x plus 3 all over x. So x is equal to a fraction whose denominator, whose d, is the same with the given fraction, which is 2x plus 3 all over x. So its denominator should be x. Now we will be looking for a numerator that when we divide it by x, the answer is equal to x. So basically, we have x squared. Why x squared? Because x squared divided by x, the answer is x. Now that we know that x can be expressed as a fraction
which is x squared over x, we can now add these two expressions because they are now both rational and they have now the same denominator. So rewriting this, we have 2x plus 3 all over x plus the equivalent fraction of x, which is x squared over x. So since we are having the same denominator here, which is x, we can now rewrite these fractions as 1. So we have here 2x plus 3 for the first fraction, plus for the second fraction, which is x squared. And their denominator is both x. Now, we may proceed with combining like terms. But unfortunately, we do not have like terms here. So for instances like this that we don't have like terms, we can now proceed with arranging the terms in descending order. So arranging the terms, we will have first x squared because it has the highest degree. And then followed by positive 2x and followed by the constant, which is positive 3. And of course, the denominator x. But since the resulting function here is a rational function, then therefore we should have a restriction in its domain. So the denominator should not be equal to 0. This means we have here x should not be equal to 0. Because when we will substitute 0 into our denominator x, this will give us a resulting function which is undefined. Therefore, the final answer for this problem, f plus h of x, is equal to x squared plus 2x plus 3 all over x, where x is not equal to 0. So now that we're done answering number 1, let's have now number 2. We are looking for f minus g of the negative absolute value of negative 3. But what does it mean first? So what does negative absolute value of negative 3 mean? So negative absolute value of negative 3 means we are looking for the negative distance of negative 3 from our origin. So the distance of negative 3 from our origin is initially positive 3. Since we are talking about distance, so we have the value which is positive 3. So since we are looking for the negative distance, this means we are looking for negative 3. Thus, f of the negative absolute value of negative 3 means we are looking for f of negative 3. And also, g of the negative absolute value of negative 3 means we are looking for g of negative 3. So now we know that f of the negative absolute value of negative 3 is actually f of negative 3 minus the g of the negative absolute value of negative 3 is actually g of negative 3. So now let's evaluate first the functions f of negative 3 and then we will subtract the g of the negative 3. So let's have first f of negative 3. So the given f of x is equal to 2x plus 3 all over x. Thus, this will become now 2 of negative 3 plus 3 all over negative 3. Now, let's simplify. 2 times negative 3 is negative 6 plus 3 all over negative 3. So, negative 6 plus 3 is negative 3 all over negative 3. So, this will now become positive 1. On the other hand, g of negative 3 means we have the given g of x, which is x minus 2. Thus, this will become now negative 3 minus 2. And so, negative 3 minus 2, we have negative 5. So, f of negative 3 is 1 and g of negative 3 is negative 5. So, f of negative 3 is positive 1 minus the g of negative 3, which is negative 5. So here, 1 minus negative 5. Since we are having a double negative here, this indicates 1 plus 5. So this means 1 plus 5 is equal to 6. Therefore, f minus g of the negative absolute value of negative 3 is equal to 6. Now that we're done answering 1 and 2, let's have now number 3. So we are going to solve for the product of the functions g of x and h of x. So this means g of x multiplied to the function h of x. So the given g of x is equal to x minus 2. On the other hand, the given h of x is equal to x. So now, multiplying the two functions, we will have x times x, which is equal to x squared, and then negative 2 times x, which is equal to negative 2x. Therefore, the product of multiplying the functions g of x and h of x is equal to x squared minus 2x. So here the resulting function is a quadratic function. Why quadratic? Because it's having an exponent of 2 or a degree of 2. Therefore, since it's a quadratic function, it could take all values of x. Thus, we don't have any restriction here in its domain.
Division of functions. Let f and g be any two functions. The quotient f divided by g are the set of all real numbers common to the domain of f and g, and defined as follows. F divided by g of x is equal to the function f of x divided by the function g of x, where g of x should not be equal to 0. In dividing functions, first examine the given functions. Second, divide the numerator by the denominator. Third, simplify the answer. And fourth, you have to make sure to indicate the restriction in the domain of the resulting function. Now let's try these problems. Find the quotient given the function f of x, which is equal to x squared plus 2x minus 3, and the function g of x, which is equal to x squared minus 6x plus 5. Find number 1, f divided by g of x, and number 2, f divided by g of negative 5.
Now let's solve for number 1. So we are going to find the quotient of the functions f of x and g of x. So the given f of x is equal to x squared plus 2x minus 3 all over the given g of x, which is x squared minus 6x plus 5. So now we are going to divide x squared plus 2x minus 3 by x squared minus 6x plus 5. So we may choose with the process of long division or factoring out and cancellation. So I will be demonstrating here the process of factoring out and cancellation. So here, both numerators and denominators are trinomials. So we are going to express this as a product of binomial by the process of factoring. So the factors of the numerator x squared plus 2x minus 3 are x plus 3 and x minus 1. On the other hand, the factors of the denominator x squared minus 6x plus 5 are x minus 5 and x minus 1. From here, we can say that the restriction in our domain for our denominator not to be equal to 0, we should avoid the values of x, which are 5 and positive 1. Thus, we have here x should not be equal to 5 and 1. How did we get 5 and 1? So, we have to do this by equating the factors of the denominator to 0 and solve for the values of x. So here, we have the given factors of our denominator, x minus 5 and x minus 1. So we are going to equate these factors to 0 and we are going to solve for the x. So first, we have the first factor, x minus 5. So x minus 5 is equal to 0. X here is equal to 5. Therefore, the first restriction in our x should not be equal to 5. The second factor, x minus 1. We have x minus 1 is equal to 0. Solving for x, we have x is equal to 1. That's why we have the second restriction in our domain, which is x should not be equal to 1. So I guess you know now why x should not be equal to 5 and positive 1. So here we are going now to simplify our expression. So we have to cancel x minus 1 from both numerator and denominator, leaving us with the numerator x plus 3 over the denominator x minus 5. And still our restriction, x should not be equal to positive 5 and positive 1. So now that we are done answering number 1, let's now have number 2. So we are looking for the quotient of f of negative 5 and g of negative 5. So we will be evaluating first f of negative 5 and then we will evaluate g of negative 5. Then afterwards, we will be dividing their respective answers. So f of negative 5 is equal to, the given f of x is equal to x squared plus 2x minus 3. Thus, this will become negative 5 squared plus 2 times negative 5 minus 3. So this is now negative 5 squared is positive 25. Positive 2 and negative 5 is negative 10 and negative 3. So we have 25 minus 10 minus 3. So 25 minus 10 is 15. 15 minus 3 is positive 12. On the other hand, we have g of negative 5. So we have the given g of x, which is x squared minus x plus 5. So this will become now negative 5 squared minus 6 times negative 5 plus 5. So this will now become negative 5 squared is positive 25. Negative 6 times negative 5 is positive 30. And of course, we have positive 5. So this will now become 25 plus 30 plus 5. 25 plus 30 is 55 plus 5 is 60. Thus, we will have here the f of negative 5 is 12 divided by the g of negative 5, which is 60. So now the resulting fraction is 12 over 60. So this fraction can still be expressed in simplest form. So in expressing this in simplest form, we will divide both the numerator and the denominator by its greatest common factor, or the GCF. So the GCF of 12 and 60 is 12. So we will divide both numerator and denominator by 12. So 12 divided by 12, that is 1. And 60 divided by 12, that is 5. So therefore, the final answer here is 1/5 or 1 over 5.
Now let's have composition of functions. The composition of the function f and g is denoted by f of g and is defined by the equation f of g of x is equal to f of g of x. The domain of the composition function f of g is the set of all x such that x is in the domain of g and g of x is in the domain of f. In composition of functions, first examine the given functions. Second, replace each occurrence of x of the first function by the second function. Third, perform the resulting operations. Fourth, arrange the terms in descending order. And lastly, simplify. Let's try this. Given the functions f of x, which is equal to negative x squared plus 2, and g of x, which is equal to 2x plus 7, find number 1, f of g of x, and number 2, f of g of the negative absolute value of 2.
So now, given the functions f of x and g of x, we are going to solve for f of g of x, or by definition, we have f of g of x. So instead of having x here, we are going to substitute the entire function g of x into the x of our first function, f of x. So it goes like this. So the first function is f of x, and it is equal to negative x squared plus 2. Now, since we are going to substitute the entire function g of x, this will now become negative. Instead of having x, we have now 2x plus 7. And then, of course, we have squared and then plus 2. So we have here negative times 2x plus 7 squared plus 2. So we will have to square first 2x plus 7, and then we will multiply it by negative, and then we will add 2. So we have here negative. Now, the product of multiplying 2x plus 7 by itself is 4x squared plus 28x plus 49. And then we have plus 2. So now we will multiply the negative into 4x squared plus 28x plus 49. Thus, this will become negative 4x squared minus 28x minus 49, and of course we have the constant positive 2. Okay, for now, we are going to combine like terms. So we cannot combine anything here except negative 49 and positive 2. So we have negative 4x squared minus 28x. Negative 49 plus 2 is negative 47. Therefore, f of g of x is equal to negative 4x squared minus 28x minus 47. For number 2, we are looking for f of g of the negative absolute value of 2. So what does negative absolute value of 2 mean first? So negative absolute value of 2 means we are looking for the negative distance of 2 from 0. So the distance of 2 from 0 is positive 2. But since we are looking for the negative distance, this means we have negative 2. So basically, this is equal to f of g of negative 2. So what we are going to do first is to evaluate g of negative 2. So we have g of negative 2. This is equal to, the given g of x is 2x plus 7. So we have 2 times negative 2 plus 7. So 2 times negative 2 is negative 4 plus 7, and this is equal to positive 3. So therefore, we have now f of the answer for g of negative 2 is 3. So we are now going to evaluate f of 3. So the given f of x is equal to negative x squared plus 2. So we have now f of 3 is equal to negative, and instead of having x, we have now 3 and then squared plus 2. So following PEMDAS, we have 3 squared first, which is 9, and then multiplied to the negative. So we have negative 9 plus 2. So negative 9 plus 2 is equal to negative 7. Therefore, the answer for f of g of the negative absolute value of 2 is equal to negative 7.
That concludes our lesson for this week. I hope you are now able to add, subtract, multiply, and divide functions, as well as perform composition of functions. This is your teacher, Miss Mary Cristina Muzo Antalan, saying thank you and keep safe, Danians!